All right, so let's talk about rules of probability. Remember, you're asked to remember that A prime is the complement of A. That is, A complement consists of all the outcomes not in A. But remember that from sets, A complement is the set of all elements in the universal set which are not in the set A. So A complement consists of all outcomes not in A. A union B is the union of A and B. That is all the outcomes in A or B or in what? Both A and B. A intersect B is the intersect of what? A and B. That is all the elements in both A and B. Rule number 1, for any event A, the probability of A is less than 1 but greater than 0. A probability cannot be negative or greater than 1. A probability cannot be negative or greater than 1. The sample space, the probability of the sample space is 1. The probability of the sample space S occurring is 1. So it's like somebody saying to you, the probability, you flip a coin, the probability of getting a head or a tail. You understand? Getting a head and getting a tail is the sample space, don't it? So the probability of getting a head or a tail is what? 1. If you flip a coin, you must either get a what? A head or a tail. So the probability of the sample space is 1. We're looking at the diagram to the left. We have a set diagram where we have what? A and A complement. A is the unshaded circle and A complement is the shaded space. Since A complement and A make up the sample space, then the probability of A plus the probability of A complement is equal to the probability of the sample space, which everybody knows is equal to 1. The probability of A complement is equal to 1 minus the probability of A. Rule number 4. Since the empty set, that's the empty set, does not contain any element, the probability of the empty set is 0. Rule 5, the Venn diagram of two sets A and B suggests that to find the size of A union B, we add the size of A and the size of B. But since this involves adding A intersect B twice, we subtract A intersect B. So the probability of A union B is the probability of A plus the probability of B minus the probability of A intersect B. You should remember this rule from set notation, that the number of elements in A union B is equal to the number of elements in A plus the number of elements in B minus the number of elements in A intersect B. That is a rule from set notation. It is now extended to include probability. So the probability of A union B is the probability of A plus the probability of B minus the probability of A intersect B. Rule number 6, the probability of A intersect B complement, that is the shaded region, that green shaded region, that is green, right? That's green. They say that men are colorblind. So it's equal to the probability of A intersect B complement. Sorry, the probability of A. The probability of A is the probability of A intersect B complement plus the probability of A intersect B, which makes sense because A intersect B, sorry, A is a combination of A intersect B complement plus A intersect B. De Morgan's law, sorry, before that, for exhaustive events, the probability of A1 plus the probability of A2, whatever is equal to 1, whatever that means. Rule number 8, De Morgan's law. We're gonna have De Morgan's law somewhere, don't it? De Morgan's law, but it's not an issue, trust me. De Morgan's law is it's not De Morgan's, it's okay. I think this is the only thing De Morgan contributed to. Unit 2, okay. So A union B complement is equal to A complement plus the A union B complement is equal to A complement intersect B complement. You should have remembered this from set notation from CSEC. A intersect B complement is equal to A complement union B complement. And the shaded region in your diagram is A union B complement, which is the same as A complement intersect B complement. The other one, the shaded region, is A intersect B complement or A complement union B complement. All right, conditional probability. Before we do example 7. Two events, A and B. So here they're talking about the independent events. Two events, A and B. Two events, A and B are independent if and only if A, the probability of A intersect B is equal to the probability of A multiplied by the probability of B. This is definitely something to remember. All right, if A and B are independent events, then A complement and B complement are independent events, which is also, wow, the entire thing sounds important. Little information like this can be very troubling in an exam if the examiner asks you the right or the wrong question. So if A and B are independent events, then A complement and B complement are independent, and A events and A and B complement are independent events, and A complement and B are independent events. So this entire column of information seems useful. Conditional probability, which you would have seen from ADMAF. So if the probability of B is greater than 0, then the probability of A condition B is the probability of A intersect B divided by B, is defined as the conditional probability is defined to be the conditional probability that event A occurs given that event B has occurred. When we condition on B, we're assuming that event B has occurred so that B becomes the new probability space. Some results for conditional probability. A intersect B is equal to B condition A, the probability of B condition A multiplied by the probability of A, which is equal to the probability of A condition B multiplied by the probability of B. For any event A and B, the probability of A complement condition B is equal to 1 minus the probability of A condition B. Seems important. I always advise students to sort of, when you have an opportunity to test these results. Don't just try to swat them, test them. Because if you try to swat them, there's a possibility that you might not remember. All right. And we can probably look at, well, the first one is sort of obvious. We can probably look at the second one later. The probability of A union B condition C is equal to the probability of A condition C plus the probability of B condition C minus the probability of A intersect B condition C for events A, B, and C. It's all good if you could determine these results on your own without trying to sort them. And that's something you have to do on your own. All right, so let's have a go at example 7. Example 7 says, events A and B are such that the probability of A is 1/2, the probability of B is 1/6, the probability of A intersect B is 1/3. We're to find the probability of A intersect B and find the probability of B condition A. Do that very quickly. All right, so let's have a go at example 7. It says events A and B are such that the probability of A is 1/2, the probability of B is 1/6, the probability of A union B is equal to 1/3. We're to find the probability of A intersect B. So here's what we know. We know that the probability of A union B is equal to the probability of A plus the probability of B minus the probability of A intersect B. Let's put in what we know. This is 1/3, am I correct? This is equal to what, 1/2? Plus, what is this, 1/6? What we don't know is this. So the probability of A intersect B would be equal to 1/2 plus 1/6 minus 1/3, which is 3/6 plus 1/6 minus 2/6. So this is 4/6 minus 2/6 is 2/6, which is 1/3. Do you agree? Now, B, we're asked the probability of A condition B, the probability of B condition A is equal to the probability of what? A intersect B over the probability of A. I think that's it. The probability of B condition A is the probability of B occurring given that A has already occurred. So this is equal to the probability of A intersect B, which is 1/3. Divide by 1/2, which is 1/3, multiplied by 2/1. Dividing by 1/2 is the same as saying multiply by 2/1. This is 2/3. The probability of B condition A is equal to 2/3.